Alright, so here's a quick rundown of how commutators work. Basically, it's a way to move 3 pieces around a cube without affecting the rest of the cube. So in this case, we want to move 1 to 2, and then to 3, and then 3 goes back to 1, so it's a cycle. And we can realize that we can switch 1 and 2 using U2 with one move. This move that we use to switch 2 of the pieces is called interchange. And the layer that we do it on, which is the top layer, is called an interchange layer. So in order to move 2 to 3 to 1, we need to put 3 in a spot where it can swap with 2, so in one spot. So we could do it like so. Now 2 and 3 are swappable, but we messed up the interchange layer because now these 2 pieces mess up. So we can't do that, and so you have to do it in a way that doesn't mess up the interchange layer, but only swaps or puts 3 into the place where 1 is, so it can be swapped. We can do that by hiding 1, putting 3 in the spot, and putting it back. And so now 2 and 3 are swappable, and the interchange layer is undisturbed. So we can do the swap, undo the move we did, and then undo the swap. So we realized what we did was we moved 1 is now here, which is where 2 was, and 2 is now here, which is where 3 was, and 3 is now where 1 was, so we did a cycle. So if we do that 3 more times, we can get it back to where it was. So put the piece up, this is called an insertion, do the interchange, undo insertion, undo interchange. So now we just did one more cycle, so if we do it again, insertion, interchange, undo, insertion, undo, interchange. So that's a 3 cycle. So this here is a U-perm. Basically, it's another 3 cycle just on the top. So 1 goes to 2, 2 goes to 3, and then 3 goes all the way back to 1. And so we can actually turn this into the example before by using this as our buffer piece right here. And so now what we want is for 1 to go to 2, 2 to go to 3, and 3 to go to 1. And realize, remember, we can move 2 to 1 space using this move, same interchange layer. So we need to get 3 to 1 without disturbing the interchange layer. So we can hide 1, put 3 in, put it up, and that's our insertion. Do the interchange, undo insertion, undo interchange. So now you can tell that we basically have the same 3 cycle as before. So 1 goes to 2, and 2 goes to 3, and then 3 goes all the way back to 1. So in this case, we have interchange between 1 and 3, so we need to put 2 up there so we can put 1 to 2. So here we can move 1, swap 3's place with 2, so now they're interchangeable. So do the swap and then undo the insertion, and that solves the cube. So putting that all together, it looks like this. First commutator, second commutator. So one thing to notice is that we can actually save on moves here. So when we do the first commutator, we don't have to move it back and then do a U2. So instead we can just do a U right here. So there's one minor micro optimization we can still do here, is that we can't really do this algorithm fast. At least I can't do it fast. This is what happens if I try. The issue is because I'm doing this, swap, doing this, swap. My finger's having to move between these spots each time I do it. So instead, we can just basically turn the cube around and then have all the U moves be done with this finger. So that basically looks like this. So this is the final algorithm on what this looks like fast.